In this tutorial, we are going to talk about creating a simulation for your Onshape design using SimLab Composer. To access the Onshape Cloud Server from SimLab Composer, go to the File menu and click on Retrieve. Select Onshape from the Cloud Sources list. A web page will appear requesting you to enter your Onshape's account information. Click Sign In, then close the web page and go back to SimLab Composer. From this window, you can navigate the files on the cloud server. It is similar to the interface of the Onshape cloud system. You can access your documents, the files you created, your shared files, and also the public server. Once you select a folder from the list, the contents of this folder will be displayed in the Documents list. Select a document to display all the elements included in that document. Select an element and click Import to access the selected design from the Onshape Cloud Server through SimLab Composer. This is a universal joint design that we will simulate using SimLab Composer's Simulation Workbench. Go to the Workbench icon and select Simulation. From the Solid Editing dialog window, you can either choose specific parts to simulate or click on Auto Detect Solids to have SimLab Composer automatically convert all the objects to solids that can be simulated by the physics engine in SimLab Composer. Once you have identified the solids in the scene, click on End Solid Creation to proceed to adding links to the design. Notice that hovering over the components with the pointer highlights them in red, indicating that those parts are solids that can be simulated. Let's quickly go over the mechanism of this joint. The two ends of the joint are fixed in place by a socket that would allow them to rotate in place. The rotating rod is then connected to a small shaft through a pin, and the pin is connected to a lever that serves as a transmitter between the two ends of the mechanism. First, we need to lock the parts of the design that will not be moving in order to hold the mechanism in place. So we select the base, and from the Solid Attributes panel, we click on the Lock icon to turn it into a fixed solid. Do the same for the arms holding the rotating rods. Go to the Links menu where you can create different types of joints and forces and click on Revolute Joint. Adding a joint is connecting two solids together and applying a pattern of movement according to the type of the created joint. For this revolute joint that we created, set solid 1 to be the ground, which is translated to having an external force affecting the horizontal rod, and in this case, it's the source of the motion in this joint. Set solid 2 to be the rod, and then click on one of the rod's curvatures to denote the axis of motion for the joint. From the Joint Attributes panel, click on Enable Motor, and set the speed of the motor's rotation. Go to the Simulation menu, and click Start to play the simulation. The first rod is revolving as intended, but the other components which are not connected fell out of the scene due to the effect of gravity. You can either continue and the components will be held in place once they are connected, or you can disable gravity by going to the Simulation menu and selecting Parameters, then setting the gravity value to 0 instead of minus 9.8. To connect the small pin to the rotating rod, go to the Links menu and create a fixed joint. The fixed joint will glue the two solids together as a single solid. Set solid 1 to be the small pin, and solid 2 to be the rod. Create another revolute joint, and connect the rotating rod to the vertical component, and set the axis of rotation for this joint by clicking on the exterior curvature of the pin. Create another revolute joint to connect the vertical rod to the transmission lever, and 2 more joints to connect the lever to the rod at the other end of the device. Click Start from the simulation menu to play the simulation. An additional feature the SimLab Composer's simulation offers is creating an analysis diagram from the simulation. From the Plot Points panel, select Manage Curves. Click on the Add Channel icon and then select the solid of which you need its data to be analyzed. Select which property you need to display for the solid. You can either select one attribute to display in the diagram, or you can display multiple attributes for the same solid at once. Click OK and play the simulation. SimLab Composer's ability to produce numerical data and graphs for the simulation is a great feature that allows the user to better understand the simulation and enables him to easily modify the design to serve the purposes it's intended for in a manner which is physically accurate. Go to the Simulation menu and click on To Animation. Set the number of frames per second to display in animation and click OK. Go to the Animation Workbench and play the animation. The physical simulation has been converted to a frame-by-frame animation, which allows you to export or share your simulation as a 3D PDF or a WebGL, or create a 3D rendered video for the simulation. SimLab Composer's simulation is very simple to use and can create very accurate motion and object interactions. Using advanced mathematical and physical equations embedded within its engine, it can turn your Onshape models into living objects that won't require traditional methods of communication to explain, but rather a simple play button.